G'day, Alcard J here, and in this video we'll look at fractal Browning motion. This is quite often this cloudy image you see here. What is it? Okay, this is like taking different frequencies of Perlin noise and stacking them up on top of each other. And then the sum that you inherit from adding all these different values, different frequencies, will create this output. Now, I did have a really good link here that had some really good graphics, and it's even referenced here on Stack Exchange and on this other resource I'll link, but for some reason I just can't get it to load at the moment, but we'll persevere. There's plenty of reference material that I'll be linking that you can read up and find out how this stuff works, or just search Fractal Browning Motion. Okay, so let's try and break it down and see what we're looking at. Let's just save a new scene. Like it to FBM. Let's call it fractal. Okay, and we'll try and break down what's going to happen, and then we'll code it in. So let's duplicate this a few times. So I've mucked up the order here, haven't I? So we can make these a frequency. So I made that a frequency of these. Back where we started. Okay, so we'll make this a frequency of 1. We'll make this a frequency of 2. We'll make this a frequency of 4. Make this a frequency of 8. And we'll assign that in the inspector. So frequency 1, frequency 2, 4, 8. So you see that's doubled each time. Let's hit play and see what we have. So there is the different frequencies laid out. So how it goes is this. We start off with this frequency at an amplitude of 1. And then when we double the frequency, we're going to take half of this value. So amplitude half. And then we're going to double the frequency again. We're going to take a quarter of this value. And then double it again, and we'll take an eighth of this value. You can see if I reference this picture. So you see they're stepping up through the frequencies, but the scale here is actually the amplitude being the size is being halved each time. So we need to work out a way that we can loop through, get these different values, add them all together, and then send them back. So we're still going to use our position variables in X and Y. We're still going to have our noise value. Okay, so each one of these loops is generally called an octave. Now this post goes into the terminology and what things shouldn't be named, but we need to know how many times we're going to be looping through that. X and Y semicolon. That's why. So up in our noise variables, we'll create a public integer octaves equals, I'll just do 4. Okay, so in our fractal, we'll create a for loop. Octaves. Okay, so we still get our nx and y the same way as here. Okay, but now each time we do this loop of octaves, we have to double the frequency. Now the rate of change in frequency is normally called lacunarity. But I'm going to be using a general variable name that takes care of the lacunarity and also the amplitude. Okay, so let's create a float and call it gain, which equals to 1f. Now we're going to be modifying this as we iterate through each octave. I'll just type it all out and then explain it, and hopefully it'll be as clear as mud. Okay, so each time, and then we'll get our noise, but because we're going through a loop, we're going to add to the noise each time. So noise equals noise plus the value at the position in Perlin that we're checking. Alright? But as I said, we're going to be modifying the amplitude, how much that. We're not going to be adding the whole value each time. So we're going to multiply it by 1f divided by gain. Now how is this gain going to work? So each time we loop through, we're going to double the frequency here. Okay, so basically gain times equals 2. Alright, let's see what's happening here. So we start off gain is 1, so we just get the frequency at 1. Alright, and then we add 1 divided by 1, which is 1, so we get the whole amplitude of that sample at 1. Then we multiply by 2 here, so now gain is 2. So here our frequency is doubled, but here we are halving, so it's 1 over 2, which is half of this value. So we're adding a half. So we're adding 1 plus a half, and then the next one will be times 2 times 2 is 4, so the frequency times 4, and then it's 1 over 4, which will be a quarter. So we're going to add to it a quarter of this noise sample. Okay, so we just need to take care of one more thing, because if we keep adding to noise, we want a value between 0 and 1. Now, let's just say this returns 1 each time, so we're going to be adding 1 plus a half plus a quarter plus an eighth. Now we need to normalize this value. So I'll just do a little bit of fudgery here. Float factor equals 1f. Okay, so each time we go through a loop, so we start at 0. So each time we go through a loop, we're going to add the amplitude to this factor, and then at the end we're going to divide by that factor to normalize our value. So factor plus equals our amplitude, which is 1f divided by gain. So right here on the first loop, that'll be 1 over 1, which equals 1. So factor becomes 1. Then we multiply it by 2. Go through the next loop. This will be half. So we add half. So after we finish going through all our octaves, we'll take our noise and divide it by our factor. And this will hopefully normalize the value to between 0 and 1. And then we will return noise. Okay, so let's see if we've broken that. We're in play mode here. So we'll leave all those. And let's just duplicate that one on the end. And we're going to call this one Fractal. So this will be our sum of all these ones. And it's going to come out with this texture here. So on our fractal, let's change our noise type to fractal. And we'll start with a frequency of 1. because that's what we're starting with here. And let's see what happens. Let's save the scene, and we'll hit play. So I don't know if you can quite see it, but everything that we've implemented has worked out. We've taken this at a value of 1, we've taken this at half the value, and added this one on top of this. And then we've taken a quarter of this, and we've added it on top, and then we've taken an eighth of this, and added it on top, and the sum comes to that. So if we can show that, we change the octaves back to 1. So if we click 1, we get the same image. Now if we change it to 2, we'll add this one and this one. You see it's changed there. We'll add 3, we'll add this and this and this together. We'll see we're starting to get a bit more floaty and more cloudy. So if we bring up the frequency, so let's start with a little bit more noise there. There, we're starting to see that cloudy image. Alright. So that's basically it in a nutshell. As I said, I do a poor job of explaining things, so definitely read the resource material and it'll hopefully explain it a little bit better.